Hello everyone. Today we are going to solve May-June 2022 Physics Paper 1 Variant 2. It's Paper 1 means multiple choice questions paper. Okay, let's start the paper. So question 1 is a force of 3 Newton and a force of 4 Newton act on an object. What is the maximum possible resultant of these two forces? We know that in order to obtain maximum possible resultant, the forces must act in the same direction. It means let's suppose this is the direction of force 3 Newton and the other one 4 Newton is also acting in the same direction. In this case, only the maximum possible resultant can be obtained. So 3 plus 4, that will be 7 Newton. Right? Oh, okay. There is another case that if these forces are acting and making a triangle, two forces are joined by head to tail, like this in this way. This is 3 Newton and this one is 4 Newton. Then this third line, this will be the resultant. But in this case, this resultant can never be even equal to 7 Newton. So the greatest possible or maximum possible resultant is 7 Newton. Okay, question 2. A length of copper wire is labeled length 0.5 meter and diameter 0.5 millimeter. Which instruments are most suitable to measure accurately the length and diameter of the wire? So, since length is 0.5 meter means half a meter. So, whenever we have to measure length 1 meter or lesser than 1 meter and in unit is given in meter, the suitable instrument is meter rule. So these two options have meter rule with them. So, but in order to find out diameter of a wire which is extremely small, less than 1 millimeter, the most accurate device is micrometer. So this is the correct option, B1, means meter rule will be used to find out length and the micrometer will be used to find out diameter. Additionally, let me tell you that if length is given in several meters, like 5 meter, 7 meter, in this way, so on. So in this type of situations, we use measuring tape in order to find out length. Okay? And if some length is less than or around 15 centimeter, then we use vernier calipers in order to find out that length. Okay, next question. The graph shows the speed time graph for a parachutist who jumps from a plane but does not open his parachute immediately. So whenever a person is falling, initially its motion will be affected by air resistance. So because of air resistance, his speed will be slowed down. But now they say, at what point does he open his parachute? So whenever he opens the parachute, his speed eventually will be slowed down and he will decelerate at once. So the point where he is decelerating suddenly is option B. So that's the correct option, that he will open the parachute at point B. Next question. A 60 kg passenger enters a stationary lift. The gravitational field strength is this, 10 Newton per kg. How much does the floor of the lift, how much force does the floor of the lift exert on the passenger when the lift accelerates upwards at 2 meter per second square? That's a little trickier question. So basically in this question we have to use the concept of net force. From Newton's second law, we know that net force is basically equal to sum of the forces acting on an object. So in this case, when the lift is moving upwards, the weight of the person will act downwards, means gravity, and uplift force by chairlift or by lift will be acted upwards. So the net force in this case basically will become F, means force applied by the lift minus weight of passenger. Okay, and we know that net force is basically equal to MA. So MA is equal to F minus mg, as we know that W is equal to mg. Here we have to find out this F. So by using values, MA means mass multiplied by acceleration. Mass of the passenger is 60 kg multiplied by acceleration is 2. It should be equal to F, the force applied by the lift, minus mg, m again mass, 60 multiplied by 10. So this becomes 120 is equal to F minus 600. Minus 600 will be plus 600 when it moves to left hand side, and 120 plus 600 will be 720 Newton. So that will be the force that will be exerted by the lift. Option D. Next question. The diagram represents the moon in its orbit around the earth. Which arrow represents the direction of resultant force acting on moon at the instant shown? So we know that when a body is orbiting a circular track, the force which keeps a body in its track is centripetal force. In O level, you are required to have a concept of centripetal force and its basic definition. The centripetal force is the force that keeps a body moving in a circular orbit. So in this case, Earth is applying a centripetal force, and that centripetal force always acts towards the center of circle. So this arrow A is pointing towards the center, means Earth. So option A will be the correct one. Next question. A measuring cylinder containing water is placed on a balance. A stone is placed into the water. The diagram shows reading on the balance and reading on the measuring cylinder. So it seems a lot easier question. So initially the volume of measuring cylinder is about 20. So when we have inserted a stone in it, the volume rises to almost 35. So the volume of stone is basically 35 minus 20, which is 15 centimeter cube. And the mass reading of the measuring cylinder and water without stone is 55 gram. Now it is 92.5 grams. Subtracting both of these masses is 92.5 minus 55. We get the mass. So mass will be 92.5 minus 55 gram. So 92.5 minus 55 should be 37.5 grams. And 37.5, so we have to find out density. That will be equal to 37.5 over the volume, which was the difference of this 35 and this 20, which is 15. So we got the answer. By dividing them, we got the answer C. That's the correct one. Next question. The diagram shows a uniform solid rectangular block of weight 50 Newton that is pivoted about point P. So point P here, it is the pivot point. The height of the block is 40 centimeter. The base of the block is 8 centimeter wide. So which horizontal force F just makes the block start rotate about P? So basically we have to use concept of principle of moments here. You know that principle of moments, or the basic formula of moment, is force multiplied by distance. Distance is that distance which is perpendicular to the force. So let's talk about the weight of stone which acts from the center. Since the line of action of this weight is this one, I have drawn a dotted line here. And this weight is acting from the center, and P is the pivot point. So the distance which is perpendicular to this force is this one, which I have indicated with green. Right? This green one is the distance which is perpendicular to the force. Here is force, and here it is 90-degree angle. So this moment will be 50 multiplied by 4. And on the other hand, the other force F, its perpendicular distance is 40 centimeter, because force is acting along this line and 40 centimeter is a distance which is perpendicular. So we will write down F multiplied by 40. The moment in clockwise. So this is clockwise moment, this one is anti-clockwise moment. So we can find out F now, which will be equal to 50 multiplied by 4 over 40. Okay, so the answer will become 5 Newton. Right? The next question. The center of mass of a solid rectangular block is at its center. A small heavy weight is available. Fine. In which arrangement is the center of mass lowest? We know that center of mass is lowest when the base is widest. So we have to keep the base as wider as possible. So the base will be wider when this face or face Y is on the table. So there are two options which are having face Y on the table. Sorry. There are two options which have face Y on the table, this one and this one. Option D says with face Y on a table and a heavy weight attached centrally on the top of the block. Now what's the problem with this? Basically, when the block is placed like this, although wider base is yes, it is on the table, but if we put a heavy weight here on it, a heavy weight, due to this weight the center of mass will be shifted upwards. Okay, center of mass will be shifted upwards, so that does not seem the correct option. So the lowest center of mass will be this, only with face Y on the table, right? Let's move to the next one. The graph shows how extension of a spring depends on the force applied. Which point is the limit of proportionality? So that's quite a simple question. We know that limit of proportionality comes when graph between force and extension or between load and extension is no longer straight. So the graph is going to be curved from point C. So point C is basically the limit of proportionality, because beyond this point the graph is not straight. Next question. Yes, an elastic spring has an unstretched length of 30 centimeter. Okay, this is the original length of spring. A load of 6 Newton is hung from the spring and the length of spring is now 66 centimeter, right? The 6 Newton load is removed and the spring returns to its original length. A load of 2 Newton is now hung from the spring. Okay, fine. We have to find out new length of spring. So initially the length of spring is basically 30 centimeter. When we have suspended a load of 6 Newton, its length becomes, the total length of spring is 66 centimeter. So it means extension is 66 minus 30, that will be 36 centimeter. So by the load of 6 Newton, the extension is 36 centimeter. So when the load is 2 Newton now, what will be the extension? So it's direct proportion between extension and load. So by multiplying in cross, we get 6x is equal to 2 multiplied by 36. 6 will be divided and we get x is equal to 12 centimeter. So 12 centimeter is the extension, but since the unstretched length is 30, so the total length of the spring, as we have to find out new length of spring, means whole length. So that will be 30 plus 42, 30 plus 12, which is 42 centimeter. Okay. So this type of question of load and extension are also sometimes tricky. So you are suggested to solve these questions with attention and carefulness. Okay, next question. A barometer is an instrument used to measure atmospheric pressure. We know that. In one type of barometer, the height of a liquid in a tube is measured. In which diagram does the height h represents atmospheric pressure? So barometer, this is not a barometer A1 because it is not open on both sides. B is also not a barometer because barometer is not open. Option C and D are barometers, but the standard barometer, which is used to measure atmospheric pressure, has vacuum in its empty space here. So option D is the correct option, right? Next question. A manometer contains mercury of density 14,000 kg per meter cube. So this is the density of mercury inside it. The manometer is connected to a gas supply and the difference in the height of mercury levels is 72 millimeter. It is clearly mentioned in the diagram as well. The atmospheric pressure is 100 kilopascal. The gravitational field strength is 10 Newton per kg. So what is the pressure of the gas supply? One thing we are sure that since this gas supply has pressed this mercury downwards, because mercury level has risen from this side, it has risen, so it means the pressure of this gas must be more than atmospheric pressure. Okay, more than atmospheric pressure. So that automatically rules out option A and B. These cannot be the correct options. So option C and D, only one option from these is correct. So you should be aware of the formula that gas pressure in a manometer is measured by using this relation, atmospheric pressure. It is equal to atmospheric pressure plus pressure due to liquid, right? Liquid column. Why have we added both of these pressure? Because since this gas supply is pressing mercury and it is open from this end, open means atmospheric pressure is acting from this side. But since this gas pressure has lifted mercury, it means this pressure is more than atmospheric pressure. Even if it is equal to atmospheric pressure, this mercury level will not rise upwards. So let's use this relation, atmospheric pressure, which is 100 kilopascal, plus pressure due to liquid. We use the formula rho GH, density multiplied by gravity multiplied by height. So 100 kilopascal is basically 100 times 10 to power 3 pascal, plus density, which is 14,000, the value of G, which is 10, and height 72 millimeters. So 72 millimeters is 0.072 meter. Convert standard units. So when we solve these quantities, we get option C, the correct one, around 110 kilopascal. Next question related to information. Which device provides a continuous steady energy output for the longest time? So the device which gives most output, so that is a nuclear reactor, because nuclear reactor works with fission reaction mostly. So the fission reaction is such type of a reaction which releases energy from the nucleus, and this energy is much greater than all other sources. Next question. A load is pulled by a rope attached to a motor. The resultant force exerted by the rope on the load is shown in the diagrams. In each diagram, the load moves in the direction of the force shown and takes 10 seconds, that is the time, to travel 1 meter. In which diagram does the motor works with the greatest power? The formula to calculate power is work done over time, right? So work done over time, the distance is same everywhere, it is 1 meter. So definitely we will try the greatest force, which is 12 Newton. So 12 multiplied by 1, and since time is also the same in every situation, so option A, in which we will take 12 multiplied by 1 over 10, so that will be 1.2 joule per second. In all other options, definitely we will get the lesser answer, because we will put here, instead of 12, we will put smaller values, so the answer will be smaller. Option A is the correct one. Next question. The electrical energy supplied to a kettle is 600 kilojoule. Of this energy, 45 kilojoule is transferred to the surroundings. It means that it is wasted energy. And 15 kilojoule is used to heat the casing of the kettle. So that is also wasted energy. So in this case, wasted energy means wasted energy by the way, energy is never actually wasted, but we call that energy wasted, which converts to other forms which are not required by us. So we can call that wasted energy. In this case, it will be 45 plus 15 kilojoule, so that will be 60 kilojoule. So we have to calculate efficiency basically, and in order to calculate efficiency, we need to find out output energy, because 600 kilojoule is input. So output energy will be input minus wasted energy, means 600 minus 60. Since both quantities are in kilojoule, so we can simply subtract them. 600 minus 60, that will be 540 kilojoule. So by using the formula of efficiency, we can calculate out. Since it is not in percentage, so we won't multiply 100 with the efficiency ratio. So that will simply be output over input, means 540 over 600. So that will be 0.9. That's the correct option. Next question. How is heat energy transferred through the vacuum of space from the sun to the moon's surface? We all know that in space the mode of heat transfer is only radiation. Right? So option C is the correct one. Next question. A metal cube contains boiling water. Each vertical face of the cube is painted a different color or has a different texture. Fine. So here we will use the concept that radiation depends on color and texture of the surface, and from that we know very well that dull black surface is a good emitter and good absorber of radiation. Since it contains boiling water, means it has trapped heat inside it. So thermometer is here reading the scale, so the face which will be the good emitter will cause the greatest rise in temperature. And we know that good emitter is the dull black surface. Fine, so that's the correct option. Next question. A liquid column in a liquid in glass thermometer is 2 centimeter long at 0 degrees Celsius. The column expands by 10 centimeter when heated at 100 degrees Celsius. Measuring from P, how long is the liquid column at 30 degrees Celsius? So here we use the formula that temperature is equal to L theta minus L naught over L100 minus L naught, or L0 multiplied by 100. That's the formula. So we have to find out length. Let's take we have to find out not this length. L0 is the length at 0 degrees Celsius. We have to find out this length, L theta. So let's put values. This T is the temperature given, which is 30, is equal to L theta, let's call it X. L naught means length at 0 degrees Celsius, which is 2 centimeter, over L100, the length at 100 centimeter, which will be 12, minus again 2 multiplied by 100. Right? After solving it, we get option number C, the correct one. Because let me do a little bit working on it. 30 is equal to X minus 2 over 10 multiplied with 100. So here 0 is cancelled. This 10 will be divided there. So we will get 3 is equal to X minus 2. Minus 2 will become plus 2. So we have X is equal to 3 plus 2, which is 5 centimeter. Right? Next question. A liquid in glass thermometer consists of a bulb containing a liquid which expands into a thin capillary tube. The liquid in the thermometer is replaced by the same volume of a different liquid that expands more for the same temperature rise. So the liquid expands more, length remains same. So as liquid is expanding more, it means that liquid is more sensitive. So it will increase the sensitivity of thermometer. So it will have greater sensitivity. Option A and B both having the option of greater sensitivity. But since liquid is expanding more and length is same, so it will reach out its maximum level over a small temperature change. So that's why its range will be smaller. That's the correct option. Greater sensitivity but smaller range. Okay, next question. Steam at 110 degrees Celsius condenses on a surface to form water droplets at 100 degrees Celsius. So steam is condensing means it is a conversion from gas to liquid. So heat is given out in this kind of conversion because it is a cooling process. What happens after the steam comes into contact with the surface? So when it will come into contact with a cooler surface, the molecule will slow down and what do they say? Absorb energy or emit energy? Definitely, since they are cooling down, so they will emit energy to the surrounding. That's the correct one. So option B is the correct option. Okay. So now we will do the remaining questions in the next video. Thank you for watching.